Hi everyone, today's lesson is on right triangle trigonometry using sine, cosine, and tangent. So let's get started. Let's see how many of you remember the mnemonic SOHCAHTOA, which is written right here, stands for sine. S stands for sine, is opposite side over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse, and tangent of an angle is equal to opposite over adjacent. So in right triangle trigonometry, we are starting the unit circle. And when we're using the unit circle, what we're doing is we're going to be creating graphs in right triangles, and we're going to be starting from 0, 0. So when we're doing this, our values right here, most of our values are going to be right starting here. So from this axis, keeping in mind this is 0 degrees, and from here to here, this is 90 degrees, and all the way over here, that's 180 degrees. And if I keep going, there's my 270 degrees, and all the way around my circle, my unit circle, is 360 degrees, which it shares with 0 degrees. Okay, you are going to be starting at the angle. This right here is the angle. That angle we're going to call theta. However, there's a lot of options for theta, all Greek letters, and so let's say all of these we're going to use interchangeably, meaning angle or angles. This one right here is theta. Oops, didn't spell that right. So this one right here is theta. We have this one, which is alpha. We have this one, which is phi. We have baby omega. There you go. And most of the time, I'm going to either use theta or alpha to represent my angle, but occasionally you'll see these other angles, and there's other ones too, but these are the main ones. So you put yourself at this angle right here, this being theta. If you are here at this angle, this value here is your adjacent side, okay? This value along here, which is opposite your right angle, is called the hypotenuse, and the side opposite where your angle is the opposite side. So here's my opposite side here, here's my adjacent side, and here's my hypotenuse. So going over some trig values that we have done in the past, most of you did this in geometry. Your job is to find the following from this diagram. So let's see what you remember about right triangle trigonometry. And one of the things that you should remember is that if you don't have a third side of your triangle, if we, for example, we're missing this right side, this bottom side right here, one of the things that you can do is use Pythagorean theorem. Pythagorean theorem meaning a squared plus b squared equals c squared. So we don't know what this value is here. We'll just call it x for right now. So you would go x squared plus 12 squared is equal to 13 squared. You'd get x squared is equal to that value, 169 minus 144. So you have x squared equals 25, so x equals 5. So this value down here is 5. Keep in mind something else you learned in geometry are what's called the triplets, Pythagorean triplets. And the Pythagorean triplets are a series of triplet numbers that we use that just are like a shortcut. You memorize them, and so they're always a right triangle. So for example, you've got the 3, 4, 5 right triangle. You have this one that we just did, which is the 5, 12, 13 right triangle. You have the 7, 24, 25 right triangle, and you also have the 8, 15, 17 right triangle. And basically 3 squared plus 4 squared equals 5 squared, etc. And what you can also do, there's a pattern here, and that's 5 plus 4 is 9, square root of 9 is 3. 12 plus 13 is 25, square root of that is 5. 24 plus 25 is 49, square root of that is 7. This one doesn't work. So technically it's not a thing. It's not a pattern. It's not a sequence. It's not something that's used every time because it doesn't always work. So that's just kind of a unique thing that you might notice about it. So going back up to the top, our job is to find sine, cosine, and tangent of theta. So sine of theta, if you recall, is equal to opposite over hypotenuse. So if you put yourself here at the angle where you're at, the opposite side is 12 and your hypotenuse is 13. So sine of theta is going to equal 12 over 13, and that's your answer. Cosine of theta is adjacent over hypotenuse, so that one's going to equal 5 over 13. And lastly, tangent of theta is opposite, the 12, over adjacent. So this is going to be equal to 12 over 5. And just a note, you never make that into a mixed fraction. You just leave that as an improper fraction. Now, lastly, we on this one problem, do you recall how to find theta? Well, theta, we want to actually know the number of this angle. We want that angle measurement. So in order to find that value, you can take any of these three. You have sine, cosine, and tangent to choose from. And what you're going to do is you're going to solve for theta. So I'm going to put that down here. What we have is theta, or sine, I'm just going to use sine. So sine of theta is equal to 12 over 13. You're going to get theta by itself. The act of moving this value of sine over to the other side is the inverse of that. So you have theta equals arc sine. We write it like that, arc sine of 12 over 13. Now, keep in mind, I just said arc sine. That's what I said. But I wrote sine to the negative 1 power. That's the inverse of sine, which is arc sine. So we say arc sine, but we write sine to the negative 1 power. Okay. You're going to use a calculator for this. So using a calculator, you're going to say, you're going to go 12 divided, depending on what calculator that you have. I have 12 divided by 13. And I'm going to go arc sine of that value. And let's see, what do I get? Let's see, arc sine, let's see, parenthesis 12 divided by 13. Arc sine of that, I get 0.9230. Arc sine of that is 67.38. So that's approximately 67.38, so 0.4 degrees. So that's the value of the angle. Keep in mind that when you were to draw this angle, remember, here's 0 degrees. So you're going to start at 0 and go up to this value, which is 67.4 degrees. And so that's what that is. We started to talk a little bit about reference angles. So if this is in the first quadrant, then to get back from here down, to get back from here back down to the x-axis, then the theta reference angle would be exactly the same, which would be 67.4 degrees. The next question, too, deals with what do you remember about special right triangles? For this problem, okay, let's see. So for problem number 2, I'm going to continue on the next page. So special right triangles, what you should remember about a 45, 45, 90, basically is this side and this side are equal because both of the angles are congruent. So we have that's 45, these are both the same. So what ends up happening is the sides are the same because that's the angle, side opposite that angle, they're congruent. This being my hypotenuse or my 90-degree angle. In addition to remembering that two sides are congruent, you also remember that if that's this x, this would be the same value. This side here would be x root 2. And a way to prove that would just be use Pythagorean theorem. X squared plus x squared should equal x root 2 quantity squared. So you'd have 2x squared is equal to this is going to be x root 2 times x root 2, which is x squared. Root 2 times root 2 is root 4, which is 2. And then, of course, they're equal. Something that you might have learned in geometry might be, let's say that side's 5. This side's 5, so this side would be 5 root 2. If this side is, let's say, 10, this side's 10, this side would be 10 root 2 based on the x root 2. Let's say this side was 8 root 2. Going backwards, this side would be 8, and this would be 8. Now, the problem comes in when you have this side, and it's not an x root 2 form. So let's say it's 10. Let's say this third side here is 10. Well, how do you find this right here, the other side? So what you would do is you would take 10 and you would set it equal to x root 2. And then you would have x is equal to 10 divided by root 2. And of course, you would never leave a root on the denominator. So what you would do is you would multiply by 1 in the form of root 2 over root 2. And so now you have 10 root 2 over root 2 times root 2, which is root 4, 2. 2 cancels into 10, 5. So I get 5 root 2. If I want, so this side right here would equal 5 root 2. So practicing that again, if I have a right triangle, and I said, again, this is 3, this is 3, and these are 45, 45, 90. This would be 3 root 2. But if I told you this side was 8, okay, not a root 2, in order to go backwards, see how we had this as 10? We had started off this side being 10, and now it ended up as 5 root 2. The rule is, going backwards, is you take the value 8, you divide by 2, and you multiply by root 2. So my third side is going to be 4 root 2 and 4 root 2. Okay, you can always work that one out by multiplying, but that's just a little trick for you. This one, if you have a 30, 60, 90 right triangle, this is 30, 60, 90. This is actually an equilateral triangle where all the angles are the same. So that's 60, and that's 60, which would make that 30. So if I have a 30, 60, 90, opposite the 30-degree angle, we would call, let's say, A. Opposite the 90 is going to be twice what's across from the 30. So we call that 2A. And across from the 60 is A root 3. Okay, so if this was 5, okay, this side here would be 2 times that, which would be 10. And my third side would be 5 root 3. And that would be this side right here in the middle, this value. Okay, now let's practice a little bit with that. So let's make a right triangle, and I'm going to call that 60. Here's my 30. Here's my right angle. Again, opposite 30 is A, so let's call that 3. Opposite the 90 is 2A. We're going to call that 6. And opposite the 60 is A root 3. So that's going to be 3 root 3. Let's do another example. Let's say they're opposite the 90 degrees is 10. So that means if that's equal to 2A, then A is 5. So opposite the 30 would be 5, and opposite the 60 would be 5 root 3. Now these ones are pretty uneventful, pretty easy to deal with. The part where it gets a little bit tricky is when you have opposite the 60-degree angle is not a root 3 kind of form. Let's say it's just 15, okay? And if opposite, so how do you make that? How do you find A from that? And the easiest thing to do is just set that equal to A root 3. So that's equal to A root 3. So that means A is equal to 15 divided by root 3. Well, you're not going to leave a root on the denominator. So you're going to multiply by 1 in the form of root 3 over root 3. So you end up with 15 root 3 over 3, which then multiplies, or when you cancel these here, you end up getting 5 root 3. So if this side is 15, then opposite the 30 is going to be 5 root 3. And then opposite the 90 is going to be 5 root 3 times 2, which is 10 root 3. Okay? So that's a little warm up and review for from geometry. So going back to sine, cosine, and tangent, SOHCAHTOA, our mnemonic. A mnemonic is just letters that help you remember like a pattern or a formula. So, and then ka, and then toa. What this says is sine is opposite over, sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. And like a mnemonic, like one of the mnemonics that I remember from school way back in the day was homes. These are Great Lakes. This was Huron, Ontario, Michigan, Erie, and Superior. So that was one, that's a mnemonic. That's what that is. Okay, anyway, getting back to our math mnemonic, SOHCAHTOA, always remember to put yourself at the angle. You are at the angle. So if it helps you to draw yourself there, circle the theta, whatever, put yourself at the angle that you are going to be at. So we're trying to find sine of theta. So sine is opposite over hypotenuse. So that's just opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, these are our three trig functions that we've been using in algebra, geometry, and now algebra 2. However, these three here are what we call reciprocal property or reciprocal functions. The reciprocal functions of these. So basically, the reciprocal of sine of theta, which is opposite over hypotenuse, is cosecant of theta, which is hypotenuse over opposite side. Okay, secant of theta is the reciprocal function for cosine. So that would be hypotenuse over adjacent. And cotangent would be the reciprocal for opposite over adjacent, and that's going to be adjacent over opposite. So those are reciprocal functions. Reciprocal functions basically mean that, let's say, for example, cosecant of theta, that's just equal to the same thing as 1 divided by sine of theta, okay? So this is what I was just talking about. Cosecant is 1 divided by sine of theta. Secant of theta is 1 divided by cosine. And cotangent of theta is 1 divided by tangent. One other thing, we're also going to see another identity. We call these identities tangent of theta. When you're thinking of tangent of theta, tangent of theta is the same thing as sine of theta over cosine of theta. So those are equivalent. So cotangent of theta would be equal to, so cotangent of theta would be the same thing as saying cosine of theta over sine of theta. Okay? All right. I think, this is just a proof. I think we can just do a really quick proof here. Let's do that. That would be kind of fun. Cotangent of theta, so let's see. Let's just simplify only the right side. So cotangent of theta is equal to 1 over tangent. Tangent is sine of theta over cosine of theta. Well, this line here means divide. And what that means is technically I could write 1 divided by sine of theta over cosine of theta. And of course, division is the reciprocal multiplication of the right term. So you have 1 times cosine of theta over sine of theta, which is cosine of theta over sine of theta. So basically, cotangent of theta is equal to this. So something that you might have noticed about sine and cosecant, besides them being reciprocal functions, is this, that when you take sine of theta and you multiply it by cosecant of theta, okay, you're going to get 1. And a way to prove that would be sine of theta times cosecant, which is 1 over sine of theta. And then these, of course, are going to cancel out and make 1. So you have 1 equals 1. And so that's just a little mini proof. To prove that, all of these are going to equal 1 when you multiply them together. So the product of two reciprocal functions is 1. Okay. All right. So you are given this triangle right here. If you notice, this is actually a 3, 4, 5, but it's multiplied by 2. Anyway, we call it 6, 8, 10. Your job is to find the 6 trig ratios given this triangle right here on the right. So what I'd like you to do is to stop the video for a second and try to do these on your own. Okay, so hopefully you did these on your own. And again, when you're finding sine of theta or anything of theta, you always put yourself at that angle, okay? So sine would be opposite over hypotenuse. So that's going to be 8 over 10. And I wouldn't leave that like that because you're always going to reduce. So let's reduce by 2. And so reducing by 2 is going to be 4 over 5, okay? You could do that in the regular triangle, but we're just going to pass on that. Cosine is going to be adjacent over hypotenuse, so that's going to be 6 over 10. Dividing by 2, I'm going to get 3 over 5. Tangent of theta is opposite over adjacent, so we have 8 over 6. Reducing that by 2 is going to be 4 over 3. And these 3 being my reciprocal functions, I don't really have to memorize opposite over hypotenuse or this or that. All I have to remember is which one the reciprocal function goes to which, because a lot of times these will be mixed up. So this one's the easiest. I think cotangent and tangent, those are the most obvious. So for cotangent of theta, that's going to be the reciprocal of that, which is 3 over 4. Now secant and cosecant, I remember when I learned this a long time ago, I remember sine SC. And then we add SC. So sine never goes with S. S never goes with S. C never goes with C. It's always SC, which is a great college, by the way. So sine of theta is reciprocal function of cosecant of theta. So those are going to be flipped. So you have 5 over 4. And then cosine and secant are reciprocal functions. So we just have to divide or flip those over. And we get 5 over 3. Now, the last ones are to find theta. Now remember, to find theta, I just need one of these values. And I have actually all of these. I could choose any of these. And that's something that you could try because whether you choose sine or cosine, I would just use the first one, doesn't matter. So we have sine of theta is equal to 4 over 5. So to find theta, to get theta by itself, you need to take sine and move it to the other side. And moving something to the other side is the inverse. Now, a lot of you have been doing this for years and years. For example, if you have like x plus 5 equals 10, how do you get this 5 over to the other side? Well, you would subtract 5, right? Well, that's the inverse of positive 5 is minus 5. Same thing. If I had 2x is equal to 10, the inverse of multiplication is division. So I would just be dividing by 2. So for this problem right here, okay, we're moving this to the other side. Anytime you move something to the other side, that's finding the inverse. So you have theta equals arcsine of 4 over 5. Okay, so depending, like I said, depending on what calculator you have, I'm going to go 4 divided by 5, which is just 0.8. And I'm going to take arcsine of 0.8. And so by doing that, I get 53.1. So theta is equal to approximately 53.1 degrees, and I'm done. Now, I would, just for practicing, do each of these. The TI Inspire, that's my favorite calculator. The TI Inspire, what is it? CXCAS. That one will do all of these for you. If you don't have one of those TI Inspire CAS calculators, you can do ARC of all of these, but these ones are going to require a little bit of difference. So practice, try to get the same answer on that. So here's a few practice problems. The first one says, given that sine of A, is that an A or a theta? It looks like an A, actually. So sine of A, is equal to 4/5. So again, you can put yourself here at the angle if that helps you. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So your job is to find cosecant, secant, and cotangent. Actually, I didn't even need to draw the triangle because I can just take the reciprocal functions of all these. Cosecant is a reciprocal of sine. So that's just going to be, so you're going to write cosecant of A is equal to 5/4. Secant of A is going to equal to 5/3, and tangent or cotangent of A is going to equal 3/4. Okay, so for this problem right here, the second number 2, I'm going to move this down a little bit. For this triangle right here, your job is to solve all the 5 trig functions. See that? You're given this one. Okay, so sine of beta, B is beta, is equal to 6/7. So sine of the angle is 6/7. So I'm going to say this is beta, and I'm going to put myself here. Okay, here's hair. Opposite over hypotenuse. There's my right angle. So before I can actually find all 5 of the other trig functions to make 6 total, I need to find this side right here. So I'm going to use Pythagorean theorem, x squared plus 6 squared equals 7 squared, because this is not a triplet. We're going to have x squared equals 49 minus 36. So 49 minus 36 is 13. So this value right here is the square root of 13. So my x value is the square root of 13. Okay? Because when you end up getting x squared equals 13, and then you have to square root both sides to find that side. Okay? So now we have our triangle. All right, here's our triangle. And what you have to do with the triangle is you have to find the other 5 trig functions. So we already have sine. So we need cosine of beta. We need tangent of beta. We need cotangent of beta. We need cosecant of beta. And we need secant of beta. And beta, again, is just another angle. All right, so cosine, going back to the angle, here's beta. Cosine is adjacent over hypotenuse, so that's going to be √13/7. Tangent is opposite over adjacent, so 6/√13. Now, just real quick before I move on, you are not allowed, well, most teachers will not allow you to leave a root on the denominator. So in order to get rid of a root on the denominator, you're basically multiplying it by the same value, because and this is 1, because √13/√13 is 1. So I'm allowed to multiply an expression by 1 without changing the problem. In addition, √13 times √13 is √169, which is 13. So we have 6√13/13. Cotangent is tangent flipped. So this right here, I would not go through the trouble of flipping this value here. I would flip the original, which is √13/6, and we're good. Now, cosecant is a reciprocal of sine. So sine was 6/7. So this is going to be equal to 7/6. And lastly, secant is a reciprocal of cosine. So that's going to be 7/√13. And again, do not leave the root on the denominator, but you can multiply by 1 in the form of whatever the denominator is. So this, my final answer for this one will be 7√13/13. Okay. Here's another example. Given that sine is 0.7, so I'm going to draw my angle. Sine is 0.7. Here's theta. 0.7. Let's use 7/10. Okay, so we know that sine of theta is equal to 7/10. So that's going to be opposite over hypotenuse. And then to find this side right here, we're going to go x squared, which is this value right here, plus 7 squared equals 10 squared. So x squared equals 100 minus 49. And 100 minus 49 is just going to be 51. So x is equal to 51. And so let's put that right here, square root of 51. Okay. So now we can find the other 5 trig functions. So we have sine. We need to find cosine of theta, tangent of theta, cotangent of theta, cosecant of theta, and secant of theta. So cosine of theta, put yourself at the angle. Here you are. Where's your adjacent? Because that's adjacent over hypotenuse. So that'll be square root of 51 over 10. Tangent is opposite over adjacent. And again, we're not going to leave that root there on the denominator. So I'm going to multiply by root 51 over root 51. So I get 7 root 51 divided by 51. Cotangent is tangent, which was this originally flipped. So now that's going to be root 51 over 7. Cosecant is a reciprocal of sine. So going back up here, that's going to be 10 over 7. And secant being the reciprocal of cosine, that'll be 10 over the square root of 51. Again, don't leave the root on the denominator. So you're going to multiply by whatever is on the denominator, which is root 51. And so I get 10 root 51 divided by just 51. And, sometimes these two numbers will cancel, and most of the time they won't. The last thing I need to do is find the value of theta. So again, pick one of these. I'm just going to choose sine. And so in choosing sine, I get sine of theta is equal to 0.7. Theta equals arc sine of 0.7. So theta is about approximately, so I have to do that on my calculator. So 0.7 arc sine, I get 44.4. So theta is about 44.4 degrees. Okay. And that's in my first quadrant, and it looks like this would be 44. These are right triangles. Now, remember we were doing special right triangles is what these are. Special right triangles, make a note to yourself that special right triangles give you exact values. Okay? And so that means that by exact values, I'm not going to have any decimal points. So meaning if I said this was 45, 45, 90. So this is 45, 45, 90. And we're talking about a unit circle, okay? A unit circle. If that was the case, then this would be a radius of 1, 1, 1, and this would be square root of 2. Because remember our little trick here. This is x, this is x, this is x root 2. Well, if x is 1, then I have 1, 1, 1 root 2. So to find sine of 45, put yourself at an angle, okay? There, I'm going to use B here. Sine of 45 is opposite over hypotenuse, so 1 over the square root of 2. You don't leave the root on the denominator, so I'm going to multiply by root 2 over root 2. So I get root 2 over 2. And the reason is root 2 times root 2 is root 4. Square root of 4 is 2. Then I'm going to do cosine of 45. So cosine is adjacent over hypotenuse. So that's 1 over root 2. Again, multiply by root 2 over root 2, and I get root 2 over 2. This should not be a surprise to you because this being an isosceles right triangle, sine and cosine are going to be the same because we have the same sides. We have equal sides. Tangent, however, is opposite over adjacent. So that's 1 over 1, which is 1. Now, remember in the one of the previous slides, I did tell you that tangent of an angle, we'll say 45 degrees, is equal to sine of that angle divided by cosine of that angle. And that being the case, if I have root 2 over 2 divided by root 2 over 2, I'm going to get 1. And so that's just another way of confirming what I said. Now, we're going to talk about a 30, 60, 90 right triangle. Let's say we have a 30, 60 right triangle, and we're talking about our unit circle, meaning the radius is going to be 1. Across from the 30 degrees, remember, is A. Across from the 90 is 2A. And across from the 60 was A root 3. Well, if that's the case, and it is a unit circle, and A is 1, then across from the 60 is going to be 1 root 3, or just root 3. And across from the 90 is going to be 1 times 2, or just 2. So, okay, so let's figure this out. Putting yourself at the 30-degree angle, here you are, here's 30. Sine of 30 is opposite over hypotenuse, so that's 1 over 2. Cosine of 30, here's 30, is going to be adjacent, which is root 3, over 2. And tangent of 30 is going to be 1 over root 3. Again, do not leave the root on the denominator. Multiply by root 3 over root 3, and you get root 3 over 3. Now, we're going to change things up here because now we're going to be at 60. So put yourself here now as opposed to over here. So sine of 60 is root 3, opposite over hypotenuse. So root 3 over 2. Cosine of 60 is adjacent over hypotenuse, which is 1 over 2. And tangent of 60 is opposite over adjacent, so that's going to be root 3 over 1. Something to notice about these values right here, and that is, notice that these two values here and these two values here are congruent, meaning, let me say that again, sine of 30, see this, is the same as cosine of 60. And cosine of 30 is equivalent to sine of 60. And the reason is because they're called cofunctions. And that's a lesson that we're going to be doing day 2. So just introducing cofunctions. Cofunctions are complementary angles, meaning the sine of a 30 degree, see 30, is going to be equal to cosine of a 60. 30 plus 60 equals 90. And so if the angles are complementary and they're cofunctions, meaning that they are one of them's 30 and the other one's going to be 90 minus 30, then what those are equivalent. Okay. So just doing a summary of sine of 30, etc. I do want to just remind everybody that you are going to need to really work on remembering the unit circle. And I know we're going to spend a lot of time, we spent a lot of time just in quadrant 1. Here's quadrant 1, here's quadrant 2, here's quadrant 3, and then here's quadrant 4. So we are spending a lot of time in these quadrants, but in this today we spent a lot of time in just quadrant 1, meaning sine of 30, we're talking about 30, 45s, and 60. So just get in the habit of drawing your triangles starting here. And generally, across from the 30-degree angle is 1, across from the 90 is 2, across from the 60 is root 3. And if I was asking for sine of 30, so that's going to be opposite over hypotenuse, so that's 1/2. Cosine of 30, adjacent over hypotenuse, so that's going to be root 3 over 2. And tangent of 30 is 1 over root 3, which is root 3 over 3. Now, I could redraw another triangle. I could erase that too. Let me just erase part of it. How's that? And in doing that, making a 45-degree, 45, 45, 90, where this is 1, 1, square root of 2, and this is 45, 45. Sine of 45 is 1 over root 2, which is root 2 over 2. Cosine is adjacent over hypotenuse, root 2 over 2, and tangent is 1 over 1. 60-degree angle, redrawing this for a 60. Here's 60, here's 30, here's 90. So 60, so across from the 90 is 2. Here we have 1, across from the 60 is 1 root 3. So sine of 60 is root 3 over, Sine of 60 is root 3 over 2, opposite over hypotenuse. Cosine of 60 is 1/2, and tangent of 60 is root 3 over 1. So you can use a calculator for these problems. Your job is to find x. So just two examples of trying to find x. In order to find this value right here, I'm going to use this angle. I could use this angle as well, but I'm going to start with 50. I'm trying to find the opposite side, and I do have the adjacent side. So I'm asking myself, which one uses opposite and adjacent? Well, that would be tangent, because tangent of an angle is equal to opposite over adjacent. You remember that the angle always comes after the word tangent, okay? So here we go, or cosine, etc. So we have tangent of 50 degrees is equal to the opposite side over the adjacent side, okay? And so we have, I'm going to cross multiply, and I get x is equal to 27 times whatever tangent of 50 degrees is. Something to remember, and that is to please make sure that your calculator is in degree mode when you're working with degrees. So I'm going to go tangent of 50, and I'm going to multiply that by 27, and I'm going to get approximately 32.2. So x is about, and I'm going to use squiggles, 32.2. Remember, it's not a degree because we're finding the side. So this is about 32.2. Something to remember or verify, and that is the smallest angle is opposite the smallest side. The larger angle is opposite the larger side. So 40 is smaller than 50. So that means that 27 should be smaller than 32, which it is. So you can always check that. One other note on this problem right here, and that is I could have, in order to find x, so I know you can't really see it because I drew all over this, but here's my triangle. I could have done this and said tangent of 40 is equal to opposite over adjacent. And in doing that, I just create an additional step, meaning x times tangent of 40, this is in parentheses, is equal to 27. And then x equals 27 divided by whatever tangent of 40 is. You could have done that. You would get the same answer, which is 32.2, but it's just another option for you. Okay, and for this problem right here, I'm trying to find x. X is this little side here. What do I know? I'm going to look at the big triangle, actually. What I know is on the big triangle that this is a 30, 60, 90 right triangle. And opposite the right angle is equal to 2a. So a is 50. So a is opposite the 30, so that's 50. And then that means this degree here, 60. Okay, so anyway, I know that this whole part would be 50 root 3, but that's not what I need. All I needed was this. So now that I have that, I can use tangent and go opposite over adjacent. I don't have this hypotenuse, so I can't use sine and cosine. I only can use tangent. So we would say tangent of 58 degrees is equal to 50 divided by x. Cross multiplying, if I have one term on the left and one term on the right, I can cross multiply. So I have x times tangent of 58 is equal to 50 times 1. So x is equal to 50 divided by whatever tangent, 50 divided by tangent of 58. So if I didn't have a calculator, this would actually be my answer. If I do have a calculator, then I'm going to work this out, and I'm going to say 50 divided by, parentheses, 58 tangent, close parenthesis, equals, it looks like x is 31.24, so it's about 31.2. And x for this problem is this value right here. So here's some problems that I'm actually going to start out of order. I'm going to start out of order. I'm going to start with this bottom one down here. These are just right triangle trigonometry, and all you're trying to do is to find x and y. So you're going to take the triangles separate. So like this is a 30, 60, 90. Opposite the 30 is a. Opposite the 90 is going to be 2a. So that's going to be 10 root 2. Remember x root 2. So x is 10. For this one, we have a 60, 60, 60, which makes that 30. I have no sides, except for if all my angles are congruent, then all the sides are congruent. So y is 6. If it's an equilateral triangle, that makes that 3. And that's done. Across from the 60 would be 3 root 3. For this one, a 30, 60, 90, 45, 45, 90, x root 2. So this side's 10, this side's 10. Opposite the 30 is 10. Opposite the 90 is 2 times that. And opposite the 60 is going to be a root 3. But if a is 10, so y is going to equal 10 root 3. And lastly, for this one, across from this one's just a little bit tricky. Across from the 60 is a root 3. So I don't know what that, we're going to go 60 equals a root 3. So a is equal to 6 divided by root 3. I'm going to multiply by root 3 over root 3. I'm going to get 6 root 3 over 3, which means a is 2 root 3. So a is across from the 30. So that means this is 2 root 3, which means this is 2 root 3 because it goes x root 3. Well, excuse me, that's not right. X root 2. So if you know that this is x root 2 and you know that 2 root 3 is x, that's going to go right here. So we have 2 root 3 root 2, which becomes 2 root 6. And that's my answer for that problem. So that was day 1 of trigonometry. I hope that helps. Thanks.